Okay, welcome back. My name's Alex Stevenson. I'm the editor of Defense IQ and your host for this Digital Transformation in Defense webinar series. And we're looking at today digital experimentation, test and evaluation. For those joining us for the first time, past sessions can be viewed on demand in the agenda tabs where they took place. And you can also talk to other attendees by messaging them directly to exchange contact details or, grow your networks. I'm also delighted that we'll be opening up attendance to this series as of now, so it's free to everyone. And that's sort of part of our optimistic look forward as we rebuild our roadmap to in-person events and re-establishing our digital content as a resource for you all. This webinar series has been a great partner to our annual Disruptive Technology for Defense Transformation Conference, which this September will again be held online as an abundance of caution. Hopefully, DSEI earlier that month in September will go ahead as planned and we can all meet in person at events like that. But the Disruptive Technology Conference will be online in September and then hopefully definitely in person in 2022 as lots of our events do return. This webinar series provides a great opportunity to dig into some of the digital technologies in a little bit more detail and in a less formal setting than at a conference. And today we're breaking up into manageable chunks and taking a bite out of testing and evaluation and the shift that that's going with digital technologies. The panel we've pulled together should provide some excellent insights into the strategic direction that is being set in the UK, certainly, and how this problem is being tackled at that strategic level. So joining me on the panel, we have Kathy O'Carroll, who is the Global Campaign Director for Integrated Testing and Evaluation at QinetiQ, Stephen Wilcox, the Director Engineering and Safety at DENS, the UK's procurement agency, and Ian Risk, the Chief Technology Officer at the Centre for Modelling and Simulation, CFMS. Kathy has also kindly agreed to not only just bring her experience to the discussion, but also act as the moderator. So I will, leaving me in the role as the audience advocate, and I'll be watching any chat function. So if you put in any questions into the chat function, I'll help bring those into the debate. So Kathy, that said, over to you to moderate the panel discussion.
Thanks, Alex, and welcome everybody. It's great to see so many of you on this afternoon or whatever time you're in. To me, this is a really great topic, as you can imagine from my job title. But how we modernise test and evaluation and enable military capability to be taken to the front line faster, I think, really drive us in defence as we go forward. So test and evaluation has been a long-term activity, testing the safety and performance of our equipment for our frontline commands. But how we do that in the modern world when threats are increasing at pace and technology is increasing at pace and we continually need to upgrade the military capability, I think really gives a challenge to test and evaluation. But how do we start off experimenting? How do we then evaluate? And then how do we enable that to provide the right capabilities for training as well, and do that in a much more coherent way, I think is a great challenge, and one where I think digital approaches can really bring some benefit to. So I'm really pleased today to be joined by Stephen and Ian. I hope will provide some context and some thinking from our different perspectives. But I know that people on this call as well, on this webinar, will also have some different views. So please do put your questions in, do put your comments in. We're all here because none of us have the right answers and we're all trying to learn as we go. So please, we really respect your inputs as well, and we'll try and bring those in. So really looking forward to this next hour. So introduce myself a little bit more. I'm Kathy O'Carroll, as Alex said. I'm the Global Campaign Director within QinetiQ for Test and Evaluation. That role really means that I'm looking out that little bit further in terms of what our customers' needs are in evaluation. And how we need to modernise it in this modern age. I do that from QinetiQ on a global perspective, so looking at the countries of interest to QinetiQ and where we take test and evaluation. And also as well, then looking into the company and really thinking about what capability we need to be able to deliver test and evaluation in the future. So as we modernise, what are the new skills and capabilities that's going to require for us to be able to do that and deliver to our customers' needs. Previously, just quickly, I started as a scientist in the Royal Aircraft Establishment a number of years ago as a weapons scientist, but that had me doing a number of trials and modelling activities. So I, back to my scientific career, had an interest in this area. Since then, I've done some operational management, more recently business development, and then before I took this role, managed the long-term partnering agreement, which is the contract that QinetiQ has with the UK MOD for managing strategic UK MOD T&E capabilities. And that involved a period of transformation to that contract as well. And now I'm in the global campaign director role. So that's myself. I'm going to ask Stephen to similarly do an introduction and why T&E is important to you, Stephen, if you wouldn't mind.
Kathy, thanks very much, and good afternoon, everybody, or to whatever time it is, as you say. And Alex, thank you for that introduction as well. If I could perhaps introduce myself then. So, Stephen Wilcox, I'm Director of Engineering and Safety in Defence Equipment and Support. We're responsible for bringing new equipment, new capabilities, and supporting it in service for our frontline commands. And essentially, I'm a facilitator. I work with each of the domain leads for equipment across maritime, land and air to facilitate all of the engineering aspects that they need, whether that's resources, people, standards, practices. But the value and the responsibility I have is to try and bring some innovation to those approaches, to make our engineering more effective, more efficient, and bring in some of the new ideas that we need to bring to deliver capability for our frontline customers. And what we're really interested in is trying to reduce the cost of bringing in that new equipment, trying to reduce the time to get that capability to our frontline commands in a fighting capability context. But we also have some other challenges around that, particularly around environmental, for instance, where we're going to have to change the way we undertake our acquisition process, which is notoriously long, very sequential, and just really doesn't suit itself to tapping into the developments in the civil sector, for example, which is moving far faster in the green technology, low carbon type approach. So what I'm looking at is how we can change our approach, change our acquisition approach to try and allow us to be a faster follower of that technology. So the subject of a digital approach, digital T&E, is really quite key to that, and we can perhaps discuss that later. In terms of my own background, I've brought up in a career in the Royal Air Force as an engineer. I've worked with a wide range of weapons, large aircraft and fast jet projects, both in development and in frontline operations as well. And then more recently, I've worked within DNS, bringing in new equipment programs, large aircraft programs, and then I had left the Air Force and came back in as the director for engineering and safety. So very much a business I love and committed to, but very much understand what it is the frontline commands are looking for in terms of the speed and capability thereafter. Now, in terms of looking at the opportunities, the things that really catch my eye is looking at programs like SpaceX, for example, where their ability to learn and deliver real-world effects very quickly, tapping into some of the digital approaches they take, is really quite inspiring and sets a bar for, we have equipment programs that can take decades in some cases to bring in, and we really have to transform that. So it's that sort of radical approach. How do we fundamentally change how we do things? And the digital approach would appear to provide some real opportunity there, and we can discuss some of the examples that I've experienced as we take forward the discussion. So really exciting opportunity, but it is one of those subjects that's in every conversation at the moment, and everybody has the word digital twin. How do we actually deliver this, and what does it mean? What does it mean for the equipment we already have, we're going to have for a long time? What does it mean for the equipment that's starting to come in now, and how do we really use this to the best effect and deliver real benefit? So a very rich subject, I think, but a number of topics we can tap into. So I'll stop there, Kathy.
No, thanks, Stephen. Really like that. And I like that concept of revolution. So I'm sure we'll talk more on that as we go forward. And Ian, I think you're going to bring us a different perspective. So Ian, would you like to introduce yourself and kind of why this is of interest?
Yeah, of course. Hello to everyone, wherever you are and whatever time you're at. My name is Ian Risk. I'm the Chief Technical Officer for CFMS, which is the Centre for Modelling and Simulation, which is based on the Bristol Science Park. I've got close to 40 years experience in the aerospace industry. I started out with BA Systems and then with EADS and latterly with Airbus. So around the arena that Stephen's just been talking about from the other side generally. And now I'm in quite a different role, not in a large corporate, but in a smaller research and technology based organization. So we are essentially a not-for-profit digital engineering consultancy. And our purpose is really to try and improve industrial productivity through the application of digital engineering or digital innovations, if you like, but really directed towards real-world industrial challenges. So it's not really in the early stages of research. It's how do we apply some of the developments into the industrial context and make sure that those technologies are mature enough and ready to be deployed. We benefit from being quite a neutral organization in terms of we're not affiliated to any one technology, either hardware or software based. That makes us very independent in the advice that we can provide. And it's our aim is really to try and transfer technologies between one sector and another. So learning from what's going on in automotive, moving out to aerospace or into defense or into space technology, and seeing how we can make transformations happen and happen much more quickly. But we serve industry as a whole. We're not tied to any one particular market or any one particular company, or in this context, one particular field within any one organization. With digital technology, we're trying to look at the whole, but test and evaluation is a key part of that. You know, coming through the aerospace industry, I know how much test and evaluation is important to the development of in the life cycle of any product, and it consumes so much time, cost, and resources. And those resources can really be better spent getting the product right at the start rather than trying to prove it right at the end. So what we are really interested in is how we can start to apply digital technology to do more evaluations earlier on in the life cycle. Because when we look across different industries, civil aerospace is trying to get the life cycle down from development life cycle from 9 years to 5 years. Automotive is trying to go from 5 years to 3 years. And all of that is dependent on about taking time out of this development process. And test and evaluation is the bit that consumes an awful lot of that life cycle. So I think the more that we can do digitally, the more that we can do quicker is going to benefit the way in which some of those technologies, as Stephen said, how we can get those things into the field quicker and at the right, with the right level of safety and quality.
Thanks, Ian. Okay. Yeah, great. No, thank you very much. So I'm going to pose the first question. I'm going to answer it myself to start with, and then I'll ask Stephen and Ian to give a view. We haven't rehearsed any of these, so we will come at this with different perspectives. But my first question was going to be, what do we mean when we talk digital in the context of experimentation and test and evaluation? So, what do we mean when we talk digital? Because I think it's a multifaceted term that we use, and we will all use it differently and have different things in mind, I think, when we talk digital. So I come at it from a deliverer of test and evaluation services, which is what QinetiQ does for the UK MOD. And I think that historically, we have done, Ian, you just said it, test and evaluation, I think, has tended to be a physical activity which we undertake largely, historically, at the end of a program to test that an asset, a system performs, is safe to use, and it can add time in. I think the other thing it does is, if it has issues, it also adds risk in, and it can mean a certain amount of rework. So I think digital for me really means about doing things much earlier. I think, as you just said, Ian, it means using much more digital approaches earlier in the life cycle. So we all know that, digital twins are beginning to really evolve now. And how do we make use of the evolving digital twins, which are happening in industry, to really start then that assurance piece much earlier in the life cycle? How do we make that assurance piece through program, through life cycle activity, rather than something at certain points in the life cycle. So how do we use the evidence derived from model-based approaches to really underpin safety and regulatory approval as far as possible? How do we really move then to validating those models with live where we need to, but we change the paradigm from one which is we're maximizing use of model digital-based evidence to one where we're, rather than physical, and we're validating that through live testing. And how do we get the most out of the data that we generate? So we really create an evaluation digital thread that right the way through life, which is accessible by different people to make different decisions through the life of an asset and capability. So to me, there's pieces in there around modeling and simulation, but there's also a piece in there around data and reuse of data as well. And then I think I end up in a middle ground, which talks about live, virtual and constructive, and how we blend those things together when we're trying to do system of system testing to really be able to prove a capability. So just some thoughts there from me. But Ian, you probably have a different perspective. Do you want to share your thoughts on what digital means in this context?
I mean, it's not that different from where you are, really. I mean, but I think that the way you worded it in terms of it means different things to different people is very, very true. What we're trying to look at digital in the much more kind of wider context. So everything through the life cycle, going from the early stage conceptual design all the way through to disposal at the end of life. And as I said, it can mean different things to different people, from just modeling a specific process to get a better understanding of that process. It can mean visualization of data coming from a platform, or it can just mean the data acquisition that you're getting through a test program, the transmission, the storage of that data. But all of that is coming together into those two things that you mentioned, digital twin and digital thread. And those are the things that's the kind of utopian end game that everybody is working towards in order to make the products that they produce much more kind of profitable, because they can understand how those products are actually working in the field. Are they working as they were designed to be used? Are they being used in a completely different way? Can they offer new services on the back of the way the products are being used? So there's a lot of challenges associated with it, but that's really where we're kind of looking at. How do we build, when we're talking about a digital twin, it's effectively a simulation. So until you've actually got something physical, it's a simulation that you're working with. But how can we make that first physical component as mature as possible? So that's the first kind of challenge. And then looking at the thread, it's how can you start to make connectivity? And there's a huge issue here that we've got to deal with. It's an issue that's going to go on for a long time, and that's about the access to all of the data. And these are some of the challenges that we're starting to look at, because if you're looking at digital within the context of one organization, within the walls of that organization, if that's where everything about that product is owned and contained, then that's fine. As soon as you go into a global supply chain and data has to move across borders, models have to move across borders, then you get into a different world of issues. And these are some of the challenges that we have to cope with. So this is what we are trying to think about in the terms of looking at digital in the wider context. But as I say, in terms of test and evaluation specifically, our area is really trying to look at the test and evaluation process itself. We know, and again from my background and experience, there's huge amounts of downtime in any test program where sensors are checked and the systems are evaluated, and there's no reason why we can't automate some of that process, make it much more efficiently by monitoring the things digitally and looking at their performance. There's more opportunity to do more by simulation rather than actually conducting physical tests. And we need to understand and use simulation as much as we can to identify where we need to test and why we need to test. So it's not just using the benchmark of what we've done for the last 50 years of kind of test everything because the manual says so. We've really got to start to look at, again, the SpaceX kind of approach, really understand what it is that needs to be tested. Where are the big areas of uncertainty within your system? And you can identify that through simulation, and you can pick where are the real areas that you need to test. And that's what it means to us.
Thanks, Ian. No, that's great, and I agree with you. I think that fundamental rethinking of what we're doing, rather than thinking about, I did that live, how am I going to do that in modelling, I think is a thought piece we need to go through. Stephen, your perspective, what does it mean to you?
Really interesting. Well, that's really interesting, and I can relate to all of what you covered there. I think, though, if I was asked, the spotlight question, I think it would be around doing things differently. So, as I indicated in the introduction, I live in a world where everything is evidence-based. Every decision in the cycle of a new requirement right through to delivering equipment and making the most of it is very demanding of evidence, and in most cases physical evidence, to justify the safety question. Huge focus around safety, but also around capability, to make sure that we are working within very defined parameters. So the different way of working, if I look at, let's start with the equipment we've already got in service then. A lot of our equipment already contains lots of data, lots of information. We've got lots of experience of using it. And yet we're very conservative in terms of how we expand the capability envelope of that equipment. Always with safety in mind, where's the evidence? And we tend to rely very much on the physical trials, pushing that boundary a bit further. But actually the physical trials we're doing are probably in a very constrained set of parameters, whether it's weather or temperature or whatever it is. They are very constrained. So we're always a little bit nervous. Let's see the evidence, let's do the trial. There's a huge opportunity here to collect all of that data in all of its forms. And looking at the way we use simulators, using that information, using the simulators, using the data analysis to actually have confidence that we have a lot more information out there already that we can look at and use to underpin some very sensible decisions about what we can do with our equipment. So there's a whole world there. And if I, an overused term, but around the big data space. And then if I look at the new equipment, again, we work in a very sequential, there's handoffs on throughout the development, and then certification and qualification activity through to developing a safety case. And all of it is very much, we have what we have, really. And there isn't that opportunity, picking up on Ian's point, to essentially fail early, to understand where it's going to impact you in the end state and react to it in an evolving way. And in parallel, rather than after that whole sequence, start assembling your data, your evidence, to understand what it is you bring in service. And the opportunity for whatever the format is, and it may sound a trite issue, but people recognize it, that even just collating that evidence in a format and being able to use that same format as you pass it through the buyer and then off to the user can save an enormous amount of time. You know, we are mercy to the Microsoft format issue. No criticism of Microsoft here, but you know, we spend a lot of time reformatting information and data rather than doing it as we go, building up our assurance picture, building up our evidence picture in a way actually that's perfectly recognizable for our frontline users with the elements that they need as well. And so it looks, in terms of a way of doing things differently, it feels like it's a huge opportunity here to do a lot more parallel activity, get a lot more maturity in the early designs against what the users require, and actually put a lot more safety in, because we're not just providing evidence based on a select few parameters, but actually some very rich, validated models that can test a whole range of parameters. So there's benefits all round in this, in both time, cost, speed, capability, safety. All of it suggests that we can make a great opportunity to really exploit digital in the wider context. I'll stop there, Kathy.
No, that's great. Thanks, Stephen. And you've already started to pick some of this up. You were talking about opportunities there and the kind of benefits. But if I can carry on with you, Steve, what do you think good looks like? If you could, I don't know whether I'm not, 5 or 10 years, what does good look like to you? What where do you think we should be? What does that mean to you?
Well, I don't know whether I don't know where the time element sits in this, but if I had the opportunity for that magic wand, it would be that we had a agreed standard for digital models, digital twins, and actually every new piece of equipment coming through worked to that standard, so that we could integrate weapons with ships, with aircraft, with land vehicles, in a way where the information is it's a one source of information, it's captured at the right time, but we have the tools to assimilate it, whether we need to look at the capability or look at the safety aspects, etc. And that digital model actually has a life right the way through, from the very origin to development, right through to supporting the simulators in frontline use, looking at expanding capability, and even mission rehearsal. If the models are good enough, they're there then to tap in, and if we've got the standards in place, there is potentially the opportunity for that, much more exploitation across different equipment types to really deliver defensive capability, fighting capability, as opposed to the capability of that particular piece of equipment. So if I had a magic wand, that's where I would like to be. That's what good is. Maybe it's what excellent is, I don't know, but that's what good is for me.
Thanks, Stephen. And same question to you, Ian. What do you think, if you think about benefits and opportunities, and what does good look like from your perspective?
I think that the standards bit is really important, but if I were to look and think what does good really look like, it's about organizations working together in true partnership and having a much more democratized access to the data that's coming up, because I think it is one of the challenges that we have. I know that's a topic that you want to touch on later, but I certainly think that is one of the biggest difficulties is the transfer of data between organizations, because we are never ever going to work in a scenario where it's just one company, as I touched on earlier. I think we have to understand how we move information better across industrial and national boundaries, because once you get the product delivered to the customer, that product is going to be supported and operated by a whole chain of different people, and understanding how that information is going to be communicated and be communicated safely and reliably is one of the big issues that we've got to face. So if we can get that sorted, that would be good. But as a nearer term kind of objective in terms of what does good look like, certainly improving our productivity as a nation, that's the real immediate target, I would say. We hear 50% faster, 50% cheaper as some of the rhetoric used around some of the defense products of the future. And I think we've got to not focus just on time and cost, because just because something is cheaper or quicker to the market doesn't mean to say it's safer or it's more sustainable. And I think these are the things that we have to understand better. And I think we should put the focus on productivity and how we make our engineering teams the most productive in the world. And that's the most important thing for me. That's what good would look like.
Yeah. Thanks, Ian. And I agree with both of you. And I think there's maybe just another couple of points which I guess come into this, I think, as well, in terms of what good looks like. Because I think we talk a lot, don't we, about time and cost, but I think there's also some drivers here around availability of military platforms, how we do things in a digital way, releases military platforms for use by our frontline commands. And then I think there's also, and Stephen, I think, mentioned it earlier, but kind of the net zero piece as well, and how we reduce, carbon and things like that by doing things more in digital. So I think there are quite a lot of different benefits, aren't there? I think from taking a different approach here in terms of what good would look like. I'm going to turn the question to have we seen good? Have we got examples where we're beginning to see this transformation happening? And I'm going to start with you, Ian, this time. But have you got, an example or two in terms of, where you've seen the benefits of a much more digital approach? And can you just bring that to life for us?
Yeah, I mean, I think there's a number of examples that we could take, but I'd like to pick on one particular because it's in the kind of test and evaluation field. So we've done some work with a small startup company because, again, you know, one of the big things about digital, how can we use digital to expand the resource pool that can contribute to the requirements for the defence sector. So we've done some work with a small startup company based in Bristol called Inductor Sense, and they develop an acoustic emissions sensor, which can detect corrosion within pipework. So for the oil and gas industry. So going off piste a little bit from defence, but basically the essence of the device is to monitor corrosion by sending an acoustic emission ping into the pipe, changes to the sound that comes back from the pipe. You can start to detect changes in the structure and changes in the levels of corrosion that might occur. And they wanted to develop a new product, and they needed to optimize that. They wanted to, first of all, understand, could we take a model-based approach to modeling the sensor, but also overcoming the challenge of building up the test set of corrosion samples that they would need to evaluate the sensor against. Now, given the nature of corrosion is quite random, it would be a very kind of costly exercise, firstly, to create all of the physical samples and conduct the tests. And it was kind of way beyond what was in the art of the possible for a startup. So we've taken two sides to this. One is a model-based approach to looking at the sensor itself, how it functions, and then also looking at the data that would be so we were able to generate, if you like, virtually the profiles for corrosion, a set of corrosion samples, and we were able to generate something like 400,000 test samples, way beyond what would be able to be achieved physically, vary the kind of parameters quite significantly, and then throw it up as our supercomputer to optimize the device. And we were able to use that process to really understand which were the aspects of the device that had greater sensitivity to the key parameter, which was the depth of corrosion. And we were able to give them advice how to tailor the design of the device to make sure it was optimized for the purpose that it was intended for. And we were able to do that all digitally without building a physical prototype of the device and without building any test samples at all. And now they were able to optimize that design prior to actually building anything physically, which saved them a huge amount of time, a huge amount of cost. And they were able to know that the design would be absolutely tailored to the application. So that's a kind of clear example of how we can replace things, physically from a prototype perspective and from a test and evaluation perspective. So there's there's other applications that we've looked at. We've done some work with a automotive company based up north in England, and we did some design work for them to look at the existing design of the car that they had, which is a supercar, and they were driving it around Silverstone, and the key parameter is, can you save any time of this vehicle? And what we were able to do was to look at their design, and they had a number of fixed aerofoils that gave downforce at certain parts of the track. And we were again able to model the vehicle, model its motion around the track, and then actually do a design study to change the aerofoils from passive aerofoils, which were fixed, to active ones, so that we could optimize the angle of attack of the aerofoil to give maximum downforce. And we were able to advise them this would be the performance gain that you would get on the track from making this device active. And then they were able to make an investment decision as to whether or not it was worthwhile investing in that technology for a certain performance gain, because ultimately the performance gain equates to cash. So they were able, again, digitally, to be able to make that decision.
Great examples.
A couple of examples.
Yeah, it's really helpful. Thank you, Stephen. What your thoughts?
I'll give you an example. So in previous guys, I led one of the programs I led was the introduction for the UK of the A400M. And there was a particular problem with parachutists jumping simultaneously out of the back doors, the side doors behind the aircraft, and the risk of them colliding in the airflow behind as the airflow came back together. Now, it's one of these issues where a number of nations, each nation had a different way of measuring this risk. And actually trying to get out a physical test on that was taking just an incredible amount of flight test time for different attitudes, speeds, configurations, you name it. And you put into that, trying to manage up to 100 plus parachutists as well out of that is not a small flight test, as you can imagine, and with a wide range of environmental parameters. And actually sitting behind that were nations each arguing over what was the right answer anyway. And it almost became a wicked problem that nobody could solve. And so a decision was taken by Airbus at the time to create the digital model of the airflow behind the aircraft and the effect of the parachutists. Very much demonstrated it during some of the flight tests they did to show that it was a validated model, but it allowed them essentially go to each nation and demonstrate in the way they understood the risk, what the real problem was and what the hazard was against a much wider range of parameters. And it was a really good combination of real using the modeling to provide the level of evidence based on a credible subsystem model, essentially, that allowed them to get through that capability. And it worked very successfully, and we now have capability that the nations are all happy with. I think, to be honest, had we not done that, had Airbus not done that, we'd probably never solved that problem, not in the foreseeable future, just because there were too many variables within that. So really good system. And I mention that really as an example that, and I fall into it as well, which we tend to jump to, well, why don't we have a digital model for this piece of equipment? And actually what the problem is. And we need to make sure we use that, as an opportunity. It's a real capability enhancer. But in this particular scenario, there were a lot of resistance. Of course, the model can't be validated. It isn't relevant. Of course, it overcome a lot of cultural skeptics out there, and just picking up in the chat, there's what defence not used to. I think there's a general theme there of overcoming a resistance, a conservatism, but it worked very successfully and produced some really good evidence that actually I think was much more effective than we could ever have achieved just with the flight test, the real life flight test.
Brilliant. And there's so much of this, isn't there, about building confidence, I think, if you like, in terms of, people adjusting to different approaches in this and really designing for in the beginning. I guess the example that sprung to my mind when I wrote this question and thought about my answer to this question, and I think it's more around the data side, is around ship-air integration, because I think that's been going on, not in a specific program, but quite generally going on quite a journey now. About, when you're looking at aircraft and, ship combinations, how you check the capability and safety of those, but how you automate some of that data analysis and really then test where your test points want to be, how you make the most out of that data, reuse that data. And I think that's radically over the last number of years reduced the amount of live testing that needs to take place, has released platform availability, taken time out. I think it just delivers so much in terms of benefits by really having that data available to do that. We're getting close to the end of our discussion, and I'm hoping people are going to start putting their thoughts into the chat. I know there's a few already coming through. But before I hand over to Alex to bring some of those in, I guess my final question is around challenges, and we've touched on some of these before as we've spoken. I mean, I'll just kick off here with a few thoughts, and then I'll ask Stephen and Ian to build or give their thoughts. But I think we've talked about standards and I think there's a question around fidelity of digital representations. What's that? What's the right fidelity we need of digital? Sufficient and not too much. I think there is a huge piece here, and I think Ian touched on it around that commercial piece. The access to the digital representations, the access to the data, the access to the models. There is a real commercial thing here. I think this is not all about the technical challenge. I think as well for defence, I think there's a skills piece here. I think there's a lot we can learn from the civil and other sectors, but how we really transform and have the right people to be able to move into this space. And I think so much of this is about culture and barriers, and really work as an enterprise to do that. And I think that's a piece you touched on as well, Ian, in terms of if you had a magic wand, but not putting words in your mouth, Ian, but your thoughts. I know you've touched on a little bit of this already.
Yeah, I mean, I think, you know, one of the brighter things to come out of the last year is really some of the attitude changes, and certainly, you know, things like this event happening probably wouldn't have happened this way, and wouldn't been able to have accessed so many people. So I think the move towards digital is actually, you know, becoming something much more mainstream than it was before. But as I said earlier, I think that some of the biggest challenges are associated, and I think it's being picked up in the chat, that some of the biggest challenges is this kind of exchange of data and information, and how, you know, if we want to have smart products that, you know, are much more efficient, it will be reliant on how we access the data from those systems and exchange the data. So I think that's really one of the most critical things to be addressed. But looking at what are, you know, some of the challenges and barriers, you know, I often draw upon, when I'm asked this question, a recent survey that was conducted in the States by the Stevens Institute. And they interviewed something like 100 companies and asked them, you know, where they saw the opportunities, where they saw the barriers, and looked at some of the issues that they saw as inhibitors to the adoption of digital technology. And out of the top 10, the top 5 were basically human related. So it wasn't technical issues that were kind of stopping us from moving this way. It was, you know, corporate awareness, it was skills, it's management support, and culture are some of the kind of key things that are really stopping that. So the more that we can do to break down those barriers, the better. And I think, you know, that through things like demonstration, open standards, working that kind of way, the more that we can build trust in the systems, and obviously address the cybersecurity threat associated with it, which is, you know, top of everyone's agenda, just to make sure that that happens. But we've got to, if we want to exploit digital in the way we really, you know, exploit the opportunity that's there, that's what we've really got to tackle, is the cultural issues.
Yeah, thanks, Ian. Yeah, I think it's so much about trust, isn't it? And people realizing the benefits. And I think those two probably have to go hand in hand. Stephen?
Well, I absolutely agree with that. You know, we've got some really good programs coming through at the moment that are absolutely embracing digital approach. And they will definitely lead the way as far as defence equipment is concerned. You know, whether it compares with some of the great stuff out there in other commercial industries, I don't know. But we've got those people in those places. There is definitely the people issue of resistance, and it's not resistance. I don't want to. Every conversation will say yes, we should do this. It's that nervousness. It's that holding on to hard evidence that, okay, but if we do this, how do we know we're not back in the Betamax, you know, and following the wrong approach? And it has to be the openness, the simplicity, the consensus, the demonstrating, not just by having the perfect solution and waiting until that's gone through, you know, its whole life, but actually buying into a different way of doing things and evolving, becoming more agile. And in that context, I think we can learn a lot more from some of the fast developing aspects of industry. Yes, defence is quite different in terms of the capability exploitation, but there is a more agile, and fundamentally we have to become more agile in the way we bring new equipment and develop new equipment into service. So yeah, my vote is actually around the people issue, and the ability to think differently about how we manage acquisition, and fundamentally come at this from a different approach. If we just try and evolve our current acquisition process we have in defence, we just won't go there. We have to think very differently about how we acquire, and digital will be the way to help unlock that.
Great, thanks, Stephen. So, Alex, I can see some threads going on in the chat. Do you want to bring in some of those questions, debates that are going on?
there's definitely some interesting conversations going on amongst some of the attendees, which is great to see, and they're also answering their own questions, which is good to see a bit of a community developing there. But I flagged a few in the chat function if the panel want to just click on those. But I thought we'd start in the order they came in with Shona McKechnie's question about digital experimentation, especially cyber experimentation within the vibrant SME community. Is there being anything done to capture the work that's been going on in the SME community?
Stephen, do you have a view on that?
Well, it's interesting. I think where I'm going to get to is not enough, probably. You know, we are starting to build awareness, and it's whether that awareness of what's going on, inevitably we end up with we have a requirement, we're looking at how we meet that requirement, as opposed to what's out there, where's the innovation space. Now, we have teams within our organization that are very much the innovation, that are looking what our SMEs are doing out there. But I don't think we're really on the right set of rails to do that. It feels like we need to be a lot more integrated with the way this technology is being developed, as opposed to being, and perhaps if I overstate it, the judge and jury of whether it's good enough. We need to be a lot more involved with seeing what's going on out there. And I suppose what we're looking for is that part of our business needs to be more integrated with the SME world of what's being developed, what those opportunities are, and then feeding those into some of the procurement routes that we've got. So not enough, I think, is my answer.
Yeah, I think it's an interesting challenge, isn't there, as new areas come in, such as cyber, in terms of, because it will all start off with everybody trying to work out the right answer, and you can end up with, I think, with fragmentation, which is not a bad thing, I think, because well, fragmentation is, but different approaches to it. But I think there's some challenges around, you know, experimentation, cyber, etc., as to how we coalesce that and work that together through as an enterprise. I don't know, Ian, if you've got any views on that one.
No, well, I think, you know, that if I look at wider industry and wider engagement of the cyber community, the work that's being done with the academic centres of cyber excellence is a good example. That is now, you know, leveraging much more industrial engagement, and in doing that, you know, hopefully some of those academic enterprises are going to create more spin-offs. And I know from my experience within Airbus, we did a fair bit of that in the South Wales region, around the South Wales cluster of cybersecurity companies. There's a lot going on around Cheltenham, but I think it's broadening it out from the kind of GCHQ and much more into the wider, let's say, industrial implementation is the next kind of phase. You know, looking at how that community can help support issues associated with making the products much more secure from the outset, and designing for security from the outset, not trying to bolt it on at the end. Yeah.
It is worth, if I can, Kathy, just pick up on that point. It is, we are trying to go through a fundamental change at the moment from trying to build in that secure by design from the outset. We have found ourselves where we're relying on operating mitigations, and there is now a fundamental effort to really direct that we build it in the secure by design from the very beginning, and that's ramping up very, very quickly. Probably too late, but very, very quickly. Thanks,
Stephen. There's another one here, Stephen, which I'm going to kind of point in your direction, but we've talked about digital twins for testing air and sea-based weapon systems. There's a question here about, is the same going on in land-based weapon systems?
Yes, there is, and in fact, that's where we're trying to lead the way. So, in trying to, going back to earlier comments, we're trying to show some examples of where it works very well. In fact, with on a number of our weapons, looking at how we look at opportunities for digital T&E, so that we can link that with our aircraft program. So the two are running side by side with the intent of being able to integrate the two and exploit the capability and the evidence of both as they go through. The weapons one is being driven by both in terms of lifing and capability, but also in terms of what the future capability could do. So we've got industry leading very much on the capability. We've got our users very much wanting greater life, greater utility out of the kit, and far easier integration. And it's those drivers that are really allowing us, I think, a much faster and much more agile approach to the land-based weapon systems, but also then the integration then. It's not just their platforms, but integration across the board. It is very much, and I think where this is starting to work is that we are working much closer with industry on this as well, as opposed to just handing over defence requirements. Is really start to understand what industry can offer here, and then it's up to us to really try and exploit that. And working with our frontline users, we've got the TNA guys on here working with those with what the opportunities are that we can make use of, and then reversing that back down the line to have we got the right digital inputs to be able to do that? Is it in formats that we can take into our simulators to represent it? Can we create the computer model that shows what the potential is? So yeah, we're getting there. Feels very slow though, I'd say.
Yeah. There's one here around who will lead the project to standardise the digital twin thread information exchange formats across allies, and I think the allies part in that is an interesting piece as well, and the supply chain. Anybody want to
yeah, everybody on here will have a different view, and the chat picks it out. Trying to agree something, there are protocols which work very well across the board. We in defence, we are very good at writing standards, and they work in scenarios. We also work very well with our NATO colleagues in setting standards and agreeing. So the mechanisms are all there to do that. I think we need some sort of conductor to pull this together in a way that it doesn't academic project, but actually it evolves on what already works in other industries and evolves in a way where we can adopt that. It's already recognized, it's already understood by industry, and we can start to build it in a way that meets what defence is after. I think if we start with a clean sheet, we're missing a huge opportunity here. So I'm not really sure what the answer is, but it feels like we should be building on what already exists and already works, but recognizing we do have influence across international colleagues that we can exploit, and we have processes for writing it. What we need is the expertise and the guidance to be able to get those right from the start in ways that work.
Thanks, Stephen. And there's one final question here, I think, and I'll hand back to Alex, but it's around OT&E, operational test and evaluation, often thought of, late or the last thing. How do you propose to use digital twins concept to help the warfighter end user shift their input left? And I guess so often we talk about shifting T&E left, and perhaps we not forget, but shifting the OT&E piece left as well is just as key. And I think these approaches and absolutely enable us to do that. I think we've already touched on that. I think that's as much about cultural change as it is around taking stovepipes down of DT&E and OT&E and how we really do that. But Ian?
Well, I think, again, looking at the opportunities in wider industry, a big part of why we're doing digitalization is around training. So the more that we can do to train the operators, whether it's a piece of kit in the field or whether it's a manufacturing process, the more that we can do earlier on using VR or whichever kind of means as possible to get an understanding of how the systems are likely to work and to eliminate some of that trials. If you go back to my experience within aerospace, when they asked the A380 test pilot what did he feel like, it felt like the simulator, and that's that's what it was. So it really just shows how good virtual environments can actually be. So I think in bringing that sort of operational aspect, learning from what's going on within industry, and particularly, as I say, around training in manufacturing processes is being done much more kind of remotely now. And certainly the use of VR and whatever for training, for safety training in particular, within industry is a major field of exploitation of that technology. So again, that's as much, not being someone who's worked in the field in that sense, that's the best kind of recommendation I could make.
Thanks, Ian. So I think we're just about out of time. I'd just like to say a huge thank you to Stephen and Ian for all of your thoughts and the rich discussion we've had over the last. To thank everyone contributing, and I'll hand back to Alex.
Thank you, Kathy, and yeah, I'll share my thanks with that you put to Stephen and Ian as well, and also to the audience. There's been certainly some heated, well, no, that's unfair, but some lively exchanges between some of the people on lots of topics, which is great to see. Before we end the session, do send messages to each other if you want to continue those conversations outside. We're nearing the hour mark though, so we're probably done unless there's any final question that is going to come in time. It looks not. But I also want to say that later I think on the 4th of August, we're planning a second session looking at testing and evaluation, but much more from a grassroots level and what unit level grassroots innovations can be brought in to sort of complement this more strategic vision about how testing and evaluation can change with these digital technologies. So hopefully that will give another insight into this topic. And Kathy, thank you so much for moderating. It was certainly great to have you do that. I'd be a little out of my depth on many of these technical issues. And yeah, Stephen and Ian, thank you for joining us.
Pleasure.
No, thank you very much.